Today we will discuss about the chemical dosing selection. Okay, what is the purpose of chemical dosing? Why it is required? So we will see in detail. Okay, so you can see we have one of the chilled water schematic layout. Okay, where you have the chiller, right? The primary pump, secondary pump. Then you will be having a load side FCU or FHU. Then you will be having air separator, dirt separator. Then we have expansion vessel, pressurization unit, right? Then we have a system called a chemical dosing system. Okay, so the chemical dosing will be automatic or manual. Okay, automatic means it will sense the properties of the water, right? And based on the properties of the water, it will inject the chemical so that whatever the water, it will be in proper with the proper properties, right? So if it is a manual chemical dosing, if you want, there is a manual leakage, or if you want to replace some replace the water manually, then the properties of the water will be changed. Okay, to comply with the water properties, you will be adding the chemicals. Okay, so that we will see one by one. Clear, right? Okay, now I have just made one slide for the chilled water chemical treatment. Okay, so if you go to this slide, you can see that there are two systems. One is the automatic dosing system, where you can see the storage tank. Then you will be having the sensor. Then you have a pump. Okay, so you can normally, this pump will be fitted on the top of the storage tank, and this is the monitor that will be fixed near to the automatic chemical dosing. Then this is the probe sensor which will be fixed on the chilled water system. Okay, it will monitor the water properties in all the tank. Okay, say for example pH level, ion level. Okay, so then whatever the bacteria inside, it will monitor all the properties, right? So based on that, if the properties goes up or down, then what will happen? It will inject the chemicals to maintain the correct properties of the water. Clear, right? So if it is a manual chemical dosing, say for example there is somewhere leakage, okay, happen. So you are adding the water manually. Okay, say for example the properties of the water will be changed. So in that case, you can add the chemical manually by putting the chemical on the top of this funnel. Okay, so that will go into, this will mix with the water. Then you can inject the chemical water into the system. Clear, right? So this is the simple theory concept. Okay.
Sir, I have one question.
Yeah,
What is
tell
the
me.
ratio to mixing this chemical with this water?
Yeah, that I will come to. That I will come to in this below
Okay,
slide.
okay.
Okay. See, for example, chemical. I just prepared the slide here. The chemical dosing, chemical water treatment is essential to maintain the efficiency, longevity, and the cleanness of the chilled water system, which are typically used in air conditioning, refrigeration, and industrial cooling process. Okay. So you can see the proper chemical treatment helps prevent corrosion, scaling, fouling, and microbiological growth within the system. Okay. Below are the key aspects of chemical uh, treatment in chilled water system. Okay, so if you go into the chilled water system, basically there are some of the properties very important. Say for example you have a corrosion inhibitor. Okay, so as you say, this is the depends upon the manufacturer. Okay, every meter cube you will add 3 kg of chemicals, the corrosion inhibitor chemical. So this is the ratio you asked, right?
Yes,
Hitesh.
sir. Yes,
Yeah,
sir.
see, if you go to the manufacturer, okay, see, I can show you some of the catalog from different manufacturer. Okay, this is like one of the material submittal. Okay, so if you go to one of the manufacturer, okay, where you can see, you can see the chemicals, right? The cleaning chemical, you will add 1 kg per meter cube. Okay, to maintain your pH level.
Yes, sir.
Okay, and if for example if you want to maintain the corrosion inhibitor, okay, to fight with corrosion, you will add 3 kg per meter cube, so that there will be no corrosion.
Mhm.
There will be no iron particles inside. Okay, so for that you will add 3 kg per meter cube. And for microbiocide like bacteria, fungus, for to avoid that one, you will add 0.1 kg per meter cube. So this is the ratio. This is the 3 chemicals which you will use it during the flushing time, right?
So if we
So
are
what?
using the 3 kg per meter cube, then it is covered with the pH layer and this one also, no?
No, this is for corrosion inhibitor. Okay,
Mm-hmm.
to maintain the ion level, proper ion level, right? And this is for
Mm-hmm.
the pH cleaner. Okay, then this is for the microbiocide. So there are 3 type of chemicals. Okay, we will see in the
Yes,
coming
sir.
slide. We will see in the coming slide. Okay, so if you
Okay.
talk about pH cleaner, you will add 1 kg per meter cube, and for the corrosion inhibitor, you will add 3 kg per meter cube, and if it is a microbiocide dosage, you will add 0.1 kg per meter cube. Okay. So if I go into the slide, you can see the corrosion inhibitor. The purpose of corrosion inhibitor is to prevent corrosion of metal component like pipes, heat exchanger, and chiller. Say for example, all are metal pipes. Okay, so there will be corrosion on inner side. Okay, to prevent the corrosion, you will add this chemical, right? So this chemical will prevent corrosion of metal pipes. Okay, so you can see there are different type of chemicals, which is called the nitrites. Okay, molybdates, right? Commonly used in closed system to form a protective layer on metal surface. Say for example, if you are mixing with water, what will happen? This will make a layer, okay, between the chilled water pipe, then the chemicals, then the water, so that there will not be direct contact with the water, will not directly contact with the steel pipe. Okay, assume like that, right? So this will form a layer on top of the metal surface. Okay, so that there will not be any corrosion will happen. So that is why you are using this type of chemical. Then you have a phosphates or silicates. Okay, these also form protective films on metal surface to prevent oxidation, right? Because water will evaporate. So if it evaporate, it will oxide, right? Okay. Then there is another chemical called azoles, specifically used to protect copper alloys from corrosion. So this is for copper materials. Okay, so basically this is to prevent the corrosion, right? So the application, the inhibitors are added to the system water in a calculated amount to maintain an appropriate concentration, which is 3 kg per meter cube, right? Clear, right? Reswan, Suraj, Hitesh?
Yes, sir.
Yes, yes.
Yeah.
Yes, yes, okay.
Yeah. Next one you can call the scale inhibitor. Okay, the purpose you can say that to prevent formation of scale. Okay, so typically calcium carbonate, which can reduce system efficiency by impeding heat transfer. Okay, if there are a lot of scales, that scale will go into the coil. Okay, or it will block the coil. Okay, so that we will see in the coming slide. Okay, say for example, if it is a strainer, that will go and it will form, it will block the strainer, everything. So if it is there is a blockage, then what will happen? You will not have a proper chilled water flow. So if you don't have a proper chilled water flow, then your efficiency or the heat transfer will be lesser. Then you will not get proper cooling, right? To avoid that, we are going to use that chemicals, which is called polyphosphates and phosphonates. Okay, this prevent calcium and magnesium ions from depositing as a scale. Okay, so water contains, there are many properties, right? You have a different properties like calcium, magnesium, then you have a ion level, okay, pH level. So there are different properties. To control all the properties, we are using different type of chemicals, right? Okay, then you have a chelating agents used to bind material and keep them dissolved in water, right? So the application, regular testing is required to ensure that scale inhibitors are at effective level. Okay, so normally you will check manually or by automatic with the chemicals with the monitor. You can able to check what is the scale in the system. Okay, so that you can able to add the chemical or whatever required chemicals, you can add it. Okay, based on the chemicals which is suitable for to control scale formation. Okay, then the third one will be biocides. Okay, so biocides purpose to control microbiological growth, including bacteria and algae, which can cause fouling, biofilm formation and corrosion. Okay, so this particular bacteria or algae which can cause fouling, right, biofilm formation or corrosion. So to control that, we are using this type of chemicals, which is called oxidizing biocides, which is example chlorine, biamine, used to kill microorganism. Okay, the non-oxidizing biocide used for controlling bacteria that are resistant to oxidizing biocides. Okay, so the biocides are dosed periodically or continuously depending on system condition. So that normally will be 0.1 kg per meter cube. Okay, then we have a pH control. Okay, so the purpose of the pH control is to maintain appropriate pH level, usually between 7 and 9 is crucial to prevent both acid and alkaline corrosion. Okay, the chemical used alkaline agents, example sodium hydroxide, used to increase pH level. Then acidic agent, example sulfuric acid, used to lower pH level if necessary, right? So this is also application. You will monitor continuously of pH and adjustments are done as needed. So normally you will add 1 kg per meter cube. Okay, then oxygen scavengers. So the purpose of the oxygen scavengers is to reduce dissolved oxygen, which can lead to corrosion of metallic components. Okay, so you will use the chemical which is called sodium sulfite or hydroxide. These react with the dissolved oxygen to remove it from the system. Okay, so often used in system where air intrusion is a concern or in case whether the water source contains oxygen. This normally will be applicable for cooling towers, right? Because the water is always open to the atmosphere. Okay, so then you have anti-freeze additives. Okay, so in case of low temperature application, antifreeze chemicals are added to prevent freezing of the water, right? So you will use glycol, okay, ethylene or propylene, commonly used to lower the freezing point of the water. Application, the percentage of glycol is adjusted based on the required freeze protection level. Okay, then you have a filtration and side stream filtration. This is normally used in the cooling tower application, okay, because there are a lot of solid particles or soil which will enter into the system. Okay, so the purpose is to, while not a chemical, filtration is critical for removing suspended solids and maintaining clean water, right? So the methods use cartridge filter, sand filter and centrifugal separators used to remove particles that could otherwise lead to fouling or blockages. Okay, then monitoring and testing is normally required. So regular water analysis, okay, automated dosing system which we are using it, right? And importance of chemical treatment is to control the corrosion. Okay, without proper chemical treatment, a chilled water system can suffer from corrosion, leading to leaks or equipment failure. Then scale built up, okay, reducing system efficiency and increasing energy cost. Then biofouling, causing blockages, reduce flow and potential microbial induced corrosion. Okay, so this is what normally we use: corrosion inhibitor, then pH level, then after that for the biocides. Okay, so we use this type of chemicals to control the or to maintain the water quality. Okay, so the chemical treatment in chilled water system is essential for maintaining system efficiency, extending equipment life and minimizing costly repairs or downtime. Regular monitoring and proper dosing of chemicals along with the physical filtration are crucial part of the effective maintenance and strategy. Okay, so you can see that regular water analysis normally they do, okay, regular testing of pH, conductivity, corrosion inhibitor, scale inhibitor, biocide level and microbiological activity is necessary to ensure proper treatment and system performance, right? Okay, so normally we used to check all these parameters like pH level, conductivity, corrosion inhibitor, scale inhibitor. Okay, so wherever it is required, we will add that type of chemical to control pH. You have a chemical, conductivity, you have a chemical, corrosion inhibitor, you have a different chemicals, right? So to control that, but if that corrosion inhibitor level is different, then you will add that corrosion inhibitor chemicals. Clear, right? So this is just about theory part. Okay, then let us go to, we will find out what is the importance of chilled water treatment in HVAC system. Why we do the chilled water treatment, right? So you can see that why water is a critical resource in a building. So normally we use water for domestic water application, drinking water application, then for landscaping and horticulture and the major utilities such as diesel generator and HVAC systems, right? So that is why we use the water. So water is very important in all these applications, right? So normally we have a two system. One is an open system and the another one is a closed system. The open system, the water will be directly open to the atmosphere. Okay, and if you talk about closed system, it will be closed system, like it is a within the enclosed pipe. Okay, it is not open to the atmosphere, right? So here you may require more chemical treatment because it is open to atmosphere. You may require less chemical treatment, right? Because it is enclosed system. Okay, you can see the closed system. The system is used for chilled water circulation within the evaporator and AHUs, right? So this is what we have a closed system. The closed systems are not exposed to the external environment, and once the system is charged, there is usually very little water that is needed to be added to the system. Because whenever there is a small leakage, you will add the little water by means of pressurization unit, right? If there is any small leakages or if the water evaporates, then you will add a small amount of water. Okay, so that small amount of water need a treatment. Okay, not like if you go to the open system where you have a cooling tower where you will do the lot of blowdowns, right? So you will add more water. Okay, so if you do more water, then you need a more chemical treatment, right? So that is why we have a two different type of system: open system and closed system. Okay, so as the system is isolated from an external contaminant agent, the water quality at the time of filling of the system is critical, because you are adding water which is not treated water, right? You are adding fresh water from the domestic pipeline. Okay, so when you add the water, then the entire properties of the water will change. So you have to properly treat the water whenever you are adding a fresh water. Okay, the advantage of closed system: the closed system does not have a problem of scale formation, as there is no evaporation from the system because it is a closed loop, right? So if it is an open system, then you have a lot of problem with the scale formation. Say for example, cooling tower, whenever the water opens from the atmosphere, when the cooling tower, when the water sprays from in the cooling tower, what will happen? There is a the water is exposed to the atmosphere, so there are lot of solid particles, sands, which can come into the system, right? So you need a lot of chemical treatments. Okay, so you can see the eliminate contact with the water, which further prevent formation of biological contamination in the system. Say for example, this is not directly what atmosphere, so it is not directly with air. Okay, so here also there is a scale formation, there is a microbiological formation, there is a corrosion, but it is very limited, okay, compared to the open system. But still there will be formation, it will be there will be corrosion will happen, there will be chance of air directly contact into the atmosphere, because you will be adding a fresh water to the system. So there is a chance of that exposed water will be open to the atmosphere. Okay, so there is a chance of scale formation because you are adding fresh water into the system, right? Or there is a less. Actually, you cannot say no evaporation. There will be less evaporation because the water will get heated, right? Whenever it travels from one place to another place, it will heat it up. The system will get heated, right? Say for example, sometime there is a more load. Okay, so the temperature of the chilled water may be increased in some cases, so it will be getting heated up. Okay, so when it heated, then there will be evaporation. So that time you may require that time there is a chance of scale formation. Okay, so this all will happen, but it is limited in closed loop system compared to the open loop system. Okay, in the open loop system, the condenser water is an open loop where water used in the condenser is passed through the cooling tower in contact with the air for cooling. Okay, so due to the external contact, there are additional challenges of water treatment and quality. Okay, so the key issues that operation team encounters are presence of dissolved solids, result in scale formation, corrosion, and microbiological contamination. So these all three properties we have to eye on that. Okay, so we have to keep on monitoring these three properties, right? So you can see that about water. What is water? Water is H2O. Water is a universal solvent. Okay, so water impurities contain dissolved and suspended solids. Okay, so both dissolved and suspended solids are there in the water. Then in the water there is a chance of hardness, alkalinity, metal. Okay, metal like iron, copper, aluminum, zinc. Okay, so carbon dioxide will be there in the water. Okay, sodium, chlorate. So these all combined in the water, right? Okay, so when you say pure water, so how do we get pure water? The following ingredients to be removed to get pure water. Okay, say for example, you have to remove the suspended particles, dissolved solids, okay, whatever the gases, okay, and whatever the microbiological life, like free from bacteria, free from algae. So then you can say as a pure water, right? Okay, normally there are two sources of water. One is the surface water, which comes from the rain, okay, which comes from on that above the ground, okay, in the ground, which is below the ground, okay, or river, whatever it is, right? Lake, it's called a groundwater. Okay, so the source water will be low in dissolved solids, okay, high in suspended solids. Okay, so the quality changes quickly with seasons and weather. Okay, so this is from basically from rain, right? Okay, and when you talk about groundwater, you have a high in dissolved solids, low in suspended solids. Okay, high in iron and magnesium, low in oxygen, may contain sulfide gas relatively constant quality and temperature. So this is about the source of water, right? Okay, so why the need for pure water? High level of impurities can pose a major threat to industrial development, right? Removing impurity is necessary to protect and improve operation, right? So you can see the possible method to remove these impurities. So you will add different type of chemicals, right? Turbidity, okay, you have coagulation, filtration, then you do the hardness. Okay, so if you do the hardness, you have to do the softening. Okay, if it is alkalinity, then you have to do dealkalination. If you have a chloride, then you will do the demineralization, right? If it is ion, then you will filter it. Okay, so these are the possible method to remove these impurities, right? So you can see that high pH level. If you have a in the water, if you have a high pH level, what will happen? Okay, like high pH is nothing but alkalinity, more alkalinity. Okay, so you can see that inhibits bacteria. Okay, corrosive to copper, corrosive to galvanized metal. So if you have a high pH level, these all things will happen. Okay, if you have a copper material, it will corrosive. If you have a galvanized metal, it will corrosive. Okay, so you have a bacteria chance of formation, right? Then if you have a low pH level, okay, so if it is a low pH level, again it is corrosive to steel, corrosive to copper, corrosive to galvanized metal. So that is why we used to maintain proper pH level in the system. So that is why you are adding pH chemicals, right, to control the pH level. If you see in the slide, we have seen that to maintain the proper pH level, we are adding this type of chemicals, right? And this is a conductivity. Conductivity is nothing but you have a scale formation. You have a pure water, you have a distilled water, right? So measure of water is ability to conduct electricity. Pure distilled water. Pure water will not conduct an electric current, okay, because there is no scale formation, right? As mineral accumulate, conductivity increases. Okay, so the distilled water with a salt. So that is why you have a this is not a pure water. This is with the pure water. Pure water will not have any scale formation. So if you have a salt water, there is a chance of scale formation, right? Okay, then we will talk about conductivity and hardness. Okay, hardness is in water is presence of ionized minerals such as magnesium and calcium. Okay, hardness in water can cause water to form scales. If you have a hardness in the water, it can cause water to form scales. So you can see that the scale formation, how it is, right? Calcium carbonate scale, then you have a magnesium silicate scale. So if you have a scale formation, then your water quantity, okay, the water flow will be reduced. If the water flow will be reduced, then you will not get proper cooling. So you have to run your chilled water system more. Okay, so what will happen? Your energy cost will increase. Okay, also there will be no heat transfer, proper heat transfer, right? If it goes into the coil will not have a proper heat transfer, right? So the conductivity allows us to quantify the hardness. Calcium forms hard calcium carbonate scale and magnesium forms magnesium silicate in boiler, right? So the impact of water chemistry. So you can see that scaling, corrosion, fouling, and microbiological growth. Okay, so to clear that one, we can see the cooling system problem. Okay, if you have this type of problem, what will happen? Left unchecked, this problem can cause loss of heat transfer, reduced equipment life, equipment failures, lost production, lost profits, increased maintenance cost, plant shutdown, right? So if you have a scale, fouling, microbiocide, corrosion, so this is the common cooling water problems. Okay, so if you don't check this one, you have this many effects. Okay, you can see the scaling is the formation of a thin plate like piece, lamina or flake that peels off from a source of mechanical system in contact with the water. You can see the scale formation, right? You can see the scale formation here. Okay, so the scaling increases with increasing temperature. Okay, if you have a lot of scale, then you will not have a proper heat transfer. So it will increase the temperature. Scaling increases with increasing pH level. Other factor which scaling are alkalinity, conductivity, proportionate or suspended solids. Okay, velocity of the water, right? So you can see the common problems like common scales. Okay, calcium carbonate, magnesium silicate, calcium phosphate, calcium sulfate, iron oxide, iron phosphate. So these are the common scaling. Okay. So the water reaction to mechanical system, effect of scaling. So it reduces heat transfer efficiencies, decrease efficiency, increase tube failures. Sometimes if you have a lot of scales, you can see the pipe damages, increase tube failures, increase operational cost, right? So in case of corrosion, what will happen? Corrosion is the destruction of metal or alloy gradually by a chemical reaction, especially by oxidation. Okay, you can see a pipe which damage the pipe by means of corrosion, right? So the effect of corrosion is destroy system metal, reduce heat transfer efficiency, produces leaks in equipment, contaminates process fluid, okay, increases operational cost, right? Okay, so you can see the corrosion of dissolving oxygen in water doubles for every 18 °F increase in temperature. Corrosion of water increases pH level. Corrosion layer is compromised at low and high pH at higher temperatures. Okay, so your pHs between 7 and 10 give you a lower rate of corrosion. Okay, corrosion of water increases as conductivity increases. Clear, right? So this is the about a corrosion. Okay, so that is why we are adding a corrosion inhibitor, right? And if you talk about fouling, fouling is the depositing of accumulating of particles or material of mechanical systems. You can see the before how it is. After adding the chemical, you can see that. Okay, so there is a difference before and after. So if you have an effect of fouling, reduces heat transfer efficiency, decrease fluid flow because it's blockages, so you cannot have a proper fluid flow, increases system pressure to increase the pressure, increase operational cost because you will operate more to reach the temperature.
Sir,
Okay.
I have one question.
Yeah, tell me. Yes.
Regarding this fouling, now we are using this ball system. You know, we are making, there is instead of this one small ball, it is coming, and there is even it is connected with the main return. It is going to chillers, and they are removing this corrosion and everything.
Oh, the like ball. It's like it will clean the system inside.
Yeah, small ball. I will
Okay.
send the video because we
Yeah.
already installed one.
What will happen? It's a chemical ball or
It is a foam type ball. It is very, you know, it is you can see this kind of foam type small ball. I'll send the video. I
yeah.
already took the video.
Okay, that will not damage the coil. It is like
No. It is small one, small size, just like you know, marble type, small
okay.
diameter.
Okay.
So we are also using now. This is a new system. We are introducing the you know HVAC cleaning system.
Okay.
So maybe you
Okay.
aware or not? I don't know, sir.
No, we never used it in normal building application.
Okay. This for chiller also we can use this one.
Oh, okay. If it is like a common product, you can put it in the group so that everyone can see it. If it is like a
Sure.
not
No problem.
okay, so that everyone aware of that, right?
No problem. I will share in the group also.
Yeah,
But
sure.
you know, I will share. I share to you. You directly share from my group because
No
I
problem.
don't have right.
No, not in that main group. Our HVC group. HVC group,
Okay.
everyone have access.
Yes. No issue.
Yeah, HVC group. Yes.
Okay.
Okay. We can discuss also in the HVC group. Everyone have a questions. You can exchange. Okay, so that
No.
more people will be added in future, right? We can use it like MEP group. So if somebody want to discuss HVAC, they can utilize, right? To exchange information. Okay. Next we'll talk about microbiological growth. Microbiological growth is the amplification or multiplication of microorganism, right? So the bacteria of concern, you have a different type of bacteria like Legionella. Then you have a Gallionella. Okay, there are different type of chemicals. Okay, then fungi, algae, protozoa, right? So these are the microbiological. Okay, so how to control this problem? Like, okay, this talk about microbiological. That is why we are controlling microbiological. How to control these problems? There are different problems, right? Okay, so you have a scale formation. If you have a scale formation, then you have a blow down of water from a cooling tower. That is why we do the blow down, right? Now you understand what is the purpose of blow down. Okay, to reduce the scale formation. Okay, to reduce water in the system with high concentration of dissolved materials in the water can increased by evaporation and replaced by water with the low dissolved solids. So whatever in the cooling tower, you have a larger dissolved solid material. Okay, so when you do the blow down, you will remove maximum water. Okay, whatever the water periodically, then you will add the fresh water. Okay, which is low dissolved solids. Okay, so that will not damage the system. Okay, so the corrosion controller will be inhibitor or substances that retards or stop chemical reaction. Okay, you can do that corrosion inhibitor. There are different type of chemicals like nitrite, molybdate, silicate. Okay, that is what we have seen in that slide as well, right? The cathodic corrosion inhibitor form insoluble precipitate that can coat and protect the surface. Okay, precipitated films are not as tenacious as passive films and take longer to repair after system upset. Okay, you have a zinc, okay, polyspate, phosphonate, triocell. These are different type of chemicals. Then for different type of stabilized phosphate corrosion inhibitor, you have a polyphosphate, phosphonate, orthophosphonate, right? Then close to water treatment system, you have a nitrate, azole, nitrite, molybdate, azole, then molybdates, azole, okay, molybdate, phosphonate, okay, silicate or azole. Okay, so these are the different type of chemicals which we are adding in the system to control the corrosion, right? For the microbiocide, what we are doing, minimize exposure of cooling tower deads to sunlight. Okay, prevent nutrients entering cooling tower. Okay, oxidizing biocide. Clear, right? So what is the difference between oxidizing and non-oxidizing? It is given here. Oxidizing attacks on microorganism by oxidizing the cell structure, disrupting nutrients from passing across the cell wall. Okay, non-oxidizing biocides are industrial use or effective in controlling Legionella. Okay, so the type of microorganism sensitive to pH, life cycle time in system, type and extent of program, type of contaminants, that is bacteria, fungi, algae. Okay, so we are controlling the microbiological formation by adding the chemicals. So if we talk about chilled water quality standard, okay, as a standard, if you talk about any of the water, you have a pH level, total dissolved solids, right? Alkalinity, chloride, sulfate, sulfide, total hardness, total ion, ammonium, okay, then you have a silica, turbidity, total suspended solids, biological oxygen demand, chemical oxygen demand, electrical conductivity. Okay, so this is the standard quality of the water. Okay, if you talk about pH level, you should maintain 6.5 to 8. If the pH level goes high, you know what chemical to add. If the pH goes less, you know what chemical to add. Okay, if the pH level goes less, what will be the impact? You know that one. If it goes high, what will be the impact? You know, you have that idea. Okay, so if this is for the condensing water, for circulating makeup water, what is the pH level you have to maintain? Okay, what is the dissolved solids in the system? Accepted dissolved solids, alkalinity. So you can see the table for the accepted level of the water properties, right? This is same like same like air properties. Like you have a like when we talk about in the air. Okay, we talk about dry bulb temperature, wet bulb temperature. Okay, what properties to be maintained. So that is the properties of the air. Okay, this is the properties of the water, where you have a different type of material, the particles, right? Okay, say for example, if you talk about air, you have oxygen, nitrogen. Okay, different type of gases. Okay, so similarly, if you talk about water, you have a different type of as we seen in the previous, the water consists of like I think we have seen here, right? Sorry. Yeah, here the water is a H2O. It's a consist of hydrogen and oxygen, right? So you have a different type of properties you have to maintain in the system. Okay, so this is the different level. Okay, like you have a pH level, the sulfide, then you have a silica, then you have a chemical oxygen demand. Okay, so you have to maintain the water properties. Okay, in the chilled water system or condenser water system, right? So you have a chemical testing equipments. You have a different type of like a pH meter, oxygen meter to check your water properties, alkalinity, chemical strength, total hardness meter, corrosion meter, right? So what is the benefit of chemical treatment? This is the summarize. Okay, so improved performance, decreasing energy consumption, operating cost by efficient heat transfer. Okay, building consume over 20% of the world water, and HV system form a bulk of the use. So, okay, so we are using 20% of the water for the water application and HV systems. Okay, then the lower blowdown leads to lesser water use, right? So if you do proper water treatment, then you may do lesser blowdown. Okay, increase in system life expectancy. Okay, minimize risk of disease. Okay, effective and is proven in different area of application. Operation and maintenance schemes thus you thus need to understand the water quality is very important, not only to ensure that system work effectively, but also reduce the impact of HV system. Okay, so the less environmental friendly than other methods require proper disposal of chemicals. So whenever you use the chemical, you should properly discharge separately into the drainage. Okay, not in the common drainage. You have to have a proper drainage system for the chemical disposal. Okay, so this is about chilled water chemical treatment system. So we have seen the schematic diagram, right? Okay, where the system normally it will be in the section side. Okay, so whatever before entering into the equipments, like you have a pumps or chiller, before into the equipment, you are going to treat the water, then you are going to enter it. Okay, if required. Okay, and we have seen the different type of chemicals. Okay, different type of chemicals, and what is the purpose of the each uh, inhibitors, right? pH inhibitor, scale inhibitor. Okay, different type of chemicals. Okay, we have seen. Okay, and we have seen what is the importance of chemical treatment water system, why it is required. Okay, so this is just a theoretical part. You will add the chemicals based on the manufacturer recommendation for pH to control pH level. What is the percentage per meter cube you have to add for control biocides? What is the percentage or what is the amount of water per meter cube you will be adding, right? So that you can maintain the water quality in the system. It's clear?